Good morning, ma'am. I'm Eliza Irish L. Villarico, second year, taking up Bachelor of Science in Computer Engineering. Without further ado, I'll start my midterm exam presentation. Letter A, Identification. For the following equations, identify the type of equation the following is and explain or justify why. State the properties of the type and properties you've seen in the equation. Number 1. X squared plus x minus 7 is equals to 0. This is a polynomial equation that is degree 2. As we can see here, x squared. So therefore, it is a quadratic equation. Number 2. Tangent x plus 4x squared minus x is equals to 10. This is a transcendental equation that consists of trigonometric function which is tangent. As we can see here, tan x. So therefore, it is a trigonometric equation. Number 3. Log 5x plus 3x is equals to 2. This is a transcendental equation that consists of logarithmic function. As we can see here, log 5x. So therefore, it is a logarithmic equation. Number 4. X plus 7y plus 3z is equals to 0. This is a polynomial equation that is degree 1. So therefore, it is a linear equation. Number 5. X cubed over 4 plus x minus y is equals to 12. This is a polynomial equation that is degree 3. As we can see here, x cubed over 4. So therefore, it is a cubic equation. B. Solving. Number 2. Using direct method, find the solution to the following systems of equations. Complete your solutions and discuss and explain how you solve it and how you arrive to the answer. Step 1. We write down its coefficient and its constant. For matrix of coefficient, we have 4, 1, negative 1, 3, 5, 2, 2, 1, 6. And for the matrix of constant, we have 13, 21, and 14. So this is the coefficient and this is the constant. And all of them as one matrix, which is called augmented matrix. This is it. Step 2. Reduce the triangular matrix in which these and these and these are 0. By doing that, we add multiples of one equation to the others in order to eliminate a variable. First, multiply the first row into a constant that will make this 0 if we add the first row to the second row. Since it is positive 3, then what is a number we can add to it to make it 0? Negative 3, right? Thus, we have to make 4 multiplied by something that can make it negative 3. So, we multiply the entire row 1 by negative 3 over 4. And add each by row to the second row. And we get 0, 17 over 4, 11 over 4, and 45 over 4. Now we got this matrix. We'll do the same step with row 1 and row 3 in order to make the first element of row 3 a 0. As we do the same step, we encounter 2 over 4, which we can use 1/2 instead. Now this will have us use negative 1/2 as a multiplier, so we can eliminate 2 of the third row. Now we get 0, 1/2, 13 over 2, 15 over 2. Now we got this matrix. To complete the triangular form, we also have to turn this element to 0. Same step, now we use row 2 and row 3. So 1/2 divide 17 over 4 is equals to 2 over 17. This will have us use negative 2 over 17 as a multiplier to eliminate 1/2 of the third row, and now we get 0, 0, 105 over 17, 105 over 17. Now we got this matrix. And last, the step 3. Now that we are in this form we also call echelon form, we can perform backward substitution to get y by substituting z in the second row. We can actually determine the new equations now given the matrix here, such that the three equations now becomes 4x plus y minus z equals 13. 17, this is positive, 17 over 4y plus 11 for z is equals to 45 over 4. 105 over 17z is equals to 105 over 17. This shows that 105 over 17z is equals to 105 over 17. Thus we get the value of z, which is 1. Performing backward substitution, we use z is equals to 1 to get the value of y in 17 over 4y plus 11 over 4z is equals to 45 over 4. We simplify, we got y is equals to 2. With now the values of z and y, we can use them both to solve the value of x in equation 1, which is 4x plus y minus z is equals to 13. We substitute z is as 1 and y as 2. And then we simplify, we got x is equals to 3. Thus this means that for the systems of equation we found the solution where x is equals to 3, y is equals to 2, and z is equals to 1. Number 3. Using iterative method, find the solution to the following systems of equations. Complete your solutions and discuss and explain what method you use and explain how you solve it and how you arrive to the answer. Let's first get the coefficient matrix A and constant matrix B, so it will be easier for us to perform step 1. For matrix A, the coefficient, we have 1, 1, 0, 2, 1, negative 1, 3, negative 1, negative 1. And for matrix B, the constant, we have 4, 1, negative 3. Applying step 1, which are these, we arrive in this. X is equals to 4 minus y is equals to 1 minus 2x plus z, and z is equals to 3 plus 3x minus y. Then step 2, make an initial approximation of the solution. So as for initial approximation, we substitute 0 as x, y, and z. So at y is equals to 0, z is equals to 0, we substitute it to the equation of x in step 1. We get x is equals to 4. Then we use the new value of x to get y in the equation of y from step 1. So at x is equals to 4, z is equals to 0, we get y is equals to negative 7. Then we use the new value of x and y, which is 4 and negative 7, to get the value of c from the equation of c from step 1. Then we get z is equals to 22. Then the next iteration carrying the value of x, y, and z we attained from the first iteration, we use the same execution we get from step 1 and let the values of first iteration be the new variable values from step 2 and substitute for the step 3 procedure. Then we continue this iteration process. If we found that there are identical answers from iterations, we can conclude that it is the solution. But in this case, I come up with 30 iterations, but there are still no identical answers. I therefore conclude that x, y, and z are undefined. Number 4.1. Find the matrix of the minor A. To get the matrix of a minor, we use the formula AD minus CB. For this element 1, these are its ABCD. Then using the formula AD minus CB, we have 1 times 6 minus 12 times 1, which is equals to negative 6. For this element negative 2, these are its A, B, C, D. Then using the formula AD minus CB, we have 0 times 6 minus 12 times 5, which is equals to negative 60. Then for this element 3, These are its A, B, C, D. Then using the formula AD minus CB, we have 0 times 1 minus 1 times 5 is equals to negative 5. For this element 0, these are its A, B, C, D. Then using the formula AD minus CB, we have negative 2 times 6 minus 3 times 1, which is equals to negative 15. For this element 1, these are its A, B, C, D. Then using the formula AD minus CB, we have 1 times 6 minus 3 times 5 is equals to negative 9. Then for this element 12, these are its A, B, C, D. Then using the formula AD minus CB, 1 times 1 minus negative 2 times 5 is equal to 11. Then for this element 5, these are its A, B, C, D. Then using the formula AD minus CB, we have negative 2 times 12 minus 3 times 1, which is equals to negative 27. For this element 1, we have 1 times, these are its A, B, C, D. Then using the formula AD minus CB, we have 1 times 12 minus 3 times 0, which is equals to 12. Then last for this element 6, these are its A, B, C, D. Then using the formula AD minus CB, we have 1 times 1 minus negative 2 times 0, which is equal to 1. And these are the matrix of minor A. Number 4.2, find the transpose matrix of A. So, to get the transpose matrix, we're going to exchange the rows and columns. So, 105 column is going to be 105 row. Then, negative 211 column will become negative 211 row. And 312.6 column will going to be 312.6 row. And these are the transpose matrix of A. Number 4.3, find the identity matrix of A. The identity matrix of size n is the n times n square matrix whose entries on the diagonal from the upper left to the bottom right are all ones and all other entries are 0. So for that 3 by 3, we have this identity: 1 0 0 0 1 0 0 0 1 matrix, identity matrix. Number 4, find the inverse of the matrix. To get the inverse of a matrix, we use this formula, which this term refers to adjugate of a matrix. So we need to get the adjugate of a matrix. We get the minor of the matrix, then the matrix of cofactors, then we transpose the matrix cofactors. Now this is the adjugate of the matrix, which we can now substitute to this term. Then for this term, we need to find the determinant of A. 1 determinant 1 12 1 6 minus negative 2 determinant 0 12 5 6 plus 3 determinant 0 1 5 1. Then we simplify, we get negative 1, 4, 1, determinant A. Then we substitute it to this term. Now we have this. Then simplify. Negative 6 over negative 141. We got 2 over 47. Then 15 over negative 141. We got negative 5 over 47. Negative 27 over negative 141. We got 9 over 47. 60 over negative 141. We got negative 20 over 47. Negative 9 over negative 141. We got 3 over 47. Negative 12 over negative 141. We got 4 over 47. Negative 5 over negative 41. We got 5 over 141. Negative 11 over negative 141. We got 11 over 141. 1 over negative 141 is negative 1 over 141. Now, this is the inverse of this matrix. Number 4.5, find the eigenvalue and eigenvector. So, let's start first finding the eigenvalue. Now, we need to use this formula, A minus lambda identity. So, this matrix, we copy the matrix minus lambda, then its identity matrix. Then lambda times 1 from the identity matrix, we got this equation. Then we simplify this equation and we got this result. Then we find its determinants. Then we simplify. So we find its eigenvalues, and these are the results. Finding eigenvector. We're just going to use the eigenvalues and substitute it to lambda. And also, we can use, I use calculator for to easily get the eigenvector by just typing this matrix and as well is the eigenvector. So this is the result. Yeah, these are the results. That's all, ma'am. Thank you.